Dear students, welcome to the course Basic Geotechnical Engineering, Module 3, Flow Through Soils, Session number 8. I am Raja Anwar Hussain, Assistant Professor, Government Engineering College, Raichur. So here in this problem, we have to determine the average coefficient of permeability in direction parallel and perpendicular to the bedding planes of a stratified deposit of soil consisting of 3 layers of total thickness 3 meter. The top and bottom layers are 0.5 meter and 0.8 meter thick. The value of K for top, middle and bottom layers are 2 into 10 to the power of minus 4 centimeter per second, 3 into 10 to the power of minus 3 centimeter per second and 1 into 10 to the power of minus 2 centimeter per second respectively. So here, as per the given data, first of all we need to check whatever the data given here, and we need to determine the average coefficient of permeability in direction parallel and perpendicular to the bedding planes. So here the given data is the number of layers are here 3. So the total thickness of layers that is Z is equal to, here given is 3 meters. So here top and bottom layers data also it has been given. So the top layer, that is Z1, is given as 0.5 meter, and bottom layer that is Z3, it is given as 0.8 meter. So their permeability has also been given here. The value of K for top, middle, bottom layers are they have given. So that is K1 is 2 into 10 to the power of minus 4 centimeter per second, and K2 is 3 into 10 to the power of minus 3 centimeter per second, and the last one K3 for the Z3 layer is 1 into 10 to the power of minus 2 centimeter per second. So we need to calculate here average coefficient of permeability, that is parallel and perpendicular to the bedding planes, that is Kx and Ky. So we know that here, according to coefficient of permeability, parallel to the bedding planes, here the equation is Kx is equal to K1 Z1 plus K2 Z2 plus, so there are there are 3 layers are there, so up to K3 Z3. So divided by Z1 plus Z2 plus Z3. So as per the given data, if we substitute the values, that is 2 into 10 to the power of minus 4 K1 into Z1 50 plus 3 into 10 to the power of minus 3 into so here middle it has not been given, so we can calculate this middle layer as, that is we have to minus it from the total thickness of the layer is, that is Z is equal to 3 meter. If you minus with this 3 meter, that is the top layer it has been given 0.5, then bottom layer is 0.8. If you minus it, you will get the middle layer. So the middle layer will be 1.7 meters. So like this also you can write, plus 1 into 10 to the power of minus 2 into 80. So whole divided by this total thickness of layer, it is 3 meters. So the unit we want is centimeter per second, so 3 meter will be 300. So if you calculate, so it will be coming around 4.4 into 10 to the power of minus 3 centimeter per second, or Kx is equal to 0.004 centimeter per second. So this is the average permeability parallel to the bedding plane value. So now same thing we will calculate perpendicular to the, that is coefficient of permeability perpendicular to the bedding plane. So here formula is Ky is equal to capital Z divided by Z1 divided by K1 plus Z2 divided by K2 plus Z3 divided by K3. To substitute the values, it is Z1 50 divided by 2 into 10 to the power of minus 4 plus Z2 is 170 and its coefficient of permeability is 3 into 10 to the power of minus 3 plus 80 divided by 1 into 10 to the power of minus 2. So the value will be coming around Ky 0.000978 centimeter per second. So this is the average coefficient of permeability perpendicular to the bedding plane. So now let us solve one more problem. Here a canal is located in an area and is parallel to nearby river at a distance of 160 meter. Elevation of water surface in canal and river respectively are 125 meter and 150 meter. A stratum of 3 meter thick coarse grained soil whose coefficient of permeability is 2 into 10 to the power of minus 4 meter per second, sandwiched between clay strata, connects canal and the river. Calculate the seepage in meter cube per second per kilometer length of the canal and width of 3 meter respectively. So here the given data is that is L is equal to 160 meters, that is your canal distance, then we have coarse grain, that is stratum of 3 meter thick. So coarse grain thick, that is D is equal to 3 meters and its permeability is 2 into 10 to the power of minus 4 meter per second. So elevation of water surface in canal so it is given as 125 meter, whereas elevation of water surface in river, it is 150 meter. So it is 115 meter. So here we need to calculate Q value. So here we know that as per the Darcy's law, that is Q is equal to K into IA. Here discharge or seepage, that is Q is equal to K into IA, where K it is given in the problem as 2 into 10 to the power of minus 4. So I is can be written as H by L and A is B into D area. So can be written as, so H is the difference, it can be written as elevation 125 minus 115 divided by length, it is given as 160, 1 into 3. So if you calculate this, it will be coming around 3.75 into 10 to the power of minus 5 meter cube per second. So therefore Q is equal to 0.0375 meter cube per second. So this is the per kilometer length of canal. So now let us solve one more problem here. Here in this problem, the following data refers to two falling head permeability tests performed of two different soils. So the area of sample is 2800 mm square and area of standpipe is 400 mm square. Sample height of 50 mm and H1 and H2 values they are given. Sample A time taken 500 seconds and sample B 15 seconds. So determine the coefficient of permeability of each of the soil. If the two form adjacent layers 1.75 meter thick, compute the average permeability direction parallel and perpendicular to the layers. So as per the given data, that is A value, it is given. So this is a falling head method. So here A they are given as 2800 mm square and small a of that is cross section area of standpipe, it is also given 400 mm square and L is equal to 50 mm, which can also be written as 5 centimeters. Then H1 it is given H2 200 mm. Then for the time taken for sample A is 500 seconds and for sample B time taken is 15 seconds. So first we need to determine permeability, coefficient of permeability for sample A. Then next for the sample B, coefficient of permeability. Then for these coefficient of permeability we need to calculate the coefficient of permeability parallel and perpendicular to the bedding plane. So let us we will consider parallel as Kx and for perpendicular Ky. So first of all we need to determine the coefficient of permeability for soil A, then for soil B, then using these soil A and soil B values we need to determine for average coefficient of permeability parallel and perpendicular to the bedding planes. So now let us see. We know that for the falling head coefficient of permeability equation is Ka is equal to 2.303 Al divided by 80 log to the base 10 H1 by H2. So here 2.303 A is given as, that is 4 into 5 length divided by A can be written as 28 into 500 seconds in terms of then log to the base 10 H1 and H2 it is given 100 divided by 20. So here the K value will be the K value will be 2.299 into 10 to the power of minus 3 centimeter per second. So this is the coefficient of permeability for soil sample A. So now let us calculate for soil B. Same formula, divided by 80 log to the base 10 H1 divided by H2 and time taken for sample B soil is 15 seconds, then log to the base 10 100 divided by 20. So the coefficient of permeability for the soil sample B To calculate, it will be coming around 0.0766 centimeter per second. So this is the coefficient of permeability for the soil B type. So now we have to calculate the average coefficient of permeability parallel and perpendicular to the bedding planes. So average permeability that is direction parallel to the layers is given by, that is Kx is equal to soil A is Ka, coefficient of permeability is Za, plus soil B, coefficient of permeability is Kb, and Zb divided by Za plus Zb. So we know Ka value 2.299 into 10 to the power of minus 3 into Za thickness is 175 plus 0.0766 into 175 whole divided by 175 plus 175. So the value will be coming around 0.03914 centimeter per second. So similarly we have to calculate for the average coefficient of permeability perpendicular to the bedding planes. The formula here it is Ky is equal to capital Z divided by Z1 divided by K1 plus Z2 divided by K2. It can be written as, that is Za plus Zb divided by Ka plus, so as per the formula we can write it as Za, that is 175 plus 175 divided by 175 divided by 2.299 into the 10 to the power of minus 3 plus 175 divided by 0.0766. So the Ky value will be coming around 4.464 into 10 to the power of minus 3 centimeter per second. So the average permeability parallel and perpendicular to the bedding planes value are Kx is equal to 0.03914 centimeter per second. For the perpendicular to the bedding plane, the value is 4.464 into 10 to the power of minus 3 centimeter per second. So I hope that you have understood the following solved problems.